Assalamu alaikum. In today's lecture, we are going to study the probability distribution for sampling mean. But before that, we are going to have a summary of uh, previous lecture. In previous lecture, we have studied the sampling methods for probability sampling, which includes the stratified random sampling, simple random sampling, systematic random sampling, and the cluster sampling. So moving on to the methods of sampling, which in methods of probability sampling basically. So there are some terminologies we need to know before moving further. In non-probability sampling, inclusion in the sample is based on the person's judgment. But in probability sampling, each and every outcome have a equally likely chance of being selected in a sample. Non-probability sampling basically used for the exploratory research where researcher has no intention for the statistical inference. But in non-probability sampling, in probability sampling, we are saying that the sample should be unbiased representative of population. So the sampling error is basically the difference between sample statistics and the population parameter. So what is the sample statistics? Sample statistics is basically the characteristic of a sample, like sample mean, sample standard deviation, and population parameter is also like the characteristic of a population, which is the population mean and the population standard deviation. So moving further, sampling distribution of a sample mean. So the sampling distribution of a sample mean is a probability distribution. So we are going to calculate the probability distribution for sample mean of all possible means of a given sample size selected from a population. So the sample size will be given and all possible sample mean will also given. Or we will be calculated these possible sample mean after uh, drawing the all possible outcomes. So there is an example for sampling distribution of sample mean. Tortoise Industries has 7 production employees. So the data is given over here in this table. If you can see that the employees are here, total number of employees are 7 and these are hourly earnings. So this is the X, and let's see what we need to calculate in this question. What is the population mean? What is the sample distribution of the sample mean? And the sample size of 2. Third, what is the mean of sampling distribution? We need to find out the mean of sampling distribution after calculating the sampling distribution. What observation can be made about the population and the sampling distribution? So let's move on to the next slide and see the solution of this example. Whereas at first we need to calculate the population mean. So this is the similar formula as arithmetic mean. Summation of x divided by n, but we are calculating this mean for population. And this central value is equal to $7.71. Second point, this is the important point because we are calculating the sampling distribution for the very first time. To arrive at the sampling distribution of a sample mean, we need to select all possible samples of 2 without replacement from the population. If you remember in chapter 5, we have discussed the dependent and independent events, and at that point we have discussed this terminology with replacement and without replacement. So with replacement and without replacement are referring towards the dependent and independent events. Then compute the mean of each sample, and there are 21 possible samples found by using this formula, and this is the formula for combination. So we need to find out that how many outcomes uh, will be in the sample. So we are using this formula for that purpose, for finding out that all possible uh, samples. Let's move on to the next slide. So here are the possible samples of employee 2. Each sample is containing 2 employees, and this is the hourly earning. So we need to find out the mean of hourly earning. So we will find the sample mean for all possible samples of 2 employee. So this is 7 plus 7, 14 divided by 2. It will be equal to 7. And then for next point, we are going to have a 7 plus 8, which is equal to 15 divided by 2. So we will find out sample mean for each and every possible outcome. So this is how we can find out the sample mean for all possible samples of 2 employees. So this is the formula. So after finding out all the means for given sample, we will find out the sample distribution. So sum of all sample means, after finding out the uh, means, then we will sum all the sample means and divide it by the total number of samples. These were the all possible sample from with replacement with the size of 2. So this is the population distribution, and this is the distribution of sample mean. So if you can see that in this distribution we cannot make any diagram. These are two lines, these two lines are completely equal, but in this uh, distribution, if we draw a symmetrical shape on that diagram, so it seems that this is the normally distributed. So moving on to the next slide, we have a very important topic, which is central limit theorem. And central limit theorem basically used for the approximation. Okay, if all samples of a particular size are selected from any population, the sampling distribution of a sample mean is approximately a normally distributed. The approximation improves with larger sample. Okay, now if you can see in a previous example, uh, we have drawn a 21 samples of a particular size of selected population. The sample distribution of a sample mean is approximately normally distributed. If you can see this graphical view, that normal population distribution has do not a particular shape, but when we are moved towards the sample distribution, it shows us a lot more normal or a symmetrical curve on the graph. So this is called the normal distribution. When the n sample increases, it reaches to the, or you can say it closes to the normal distribution. And this approximation will improve for larger sample. So in case of binomial, we were saying that when n increases or a number of trial increases, the binomial reaches towards the normal distribution. Okay, now let's see these points. If the population follows a normal probability distribution, so if a population is following a normal probability distribution, then the sample size of sampling distribution of a sample mean will also be normal. So we can write this expression here. Expected x bar is equal to mu of x bar is equal to mu. So it means that if the population is normally distributed, then the sampling distribution will be normally distributed, and the sample mean will also normally distributed. So the next point, if the population distribution is symmetrical but not the normal shape of distribution of the sample mean emerge with the sample as small as 10. So this is the criteria that if the population distribution is symmetrical but not normal. So if the data is not normally distributed, the normal shape of distribution of a sample mean emerge sample as small as 10. It means that when the sample is small at the number 10, it means that 10 number of sample will emerge when the shape of distribution is normal. And this is the shape of normal distribution when two halves are completely equal. So this situation can be used in binomial because binomial is not symmetrical but can be normal. Okay, moving on to the next point. If the distribution that is skewed or has a thick tail, it may require samples of 30 or more to observe the normality feature. So how can we observe the normality feature if the sample of 30? It means we have n 30 or more than 30. We can say that is a greater than equal to 30. And the tail is skewed. It means that that tail is moving towards positive or negative. It's not symmetrical. You cannot say that this symmetrical is equal from both sides. At this point, we can see the normality as well. Okay, now moving on to the next slide. Next point, the mean of the sampling distribution equal to mu and the variance is equal to sigma square divided by n. So if we define in a simple way that the original population is not normally distributed, the sampling distribution of mean will be approximately normal for large sample sizes and will more closely approaches to normal distribution as sample size increases. So when the sample size increases and uh, sample distribution approaches to normality, which is called the central limit theorem. So the moving on, so let's move on to the next slide. So here we have some graphs for population and sampling distribution. So if you can see that when we draw the population on a graph, it shows a very abnormal kind of uh, data nature. For sampling distribution, if we can see when n is 20, these graphs are not depicting any information, but when we are increase the sample size, when n is increases to 6 and then it is 30, so the graph is becoming more symmetrical and showing a normal distribution shape. When n reaches to 30, it also decreases the standard error, or you can say the standard deviation from the mean. Okay, now move on to the next slide. So here we are using the sample distribution for of the sample mean when sigma is known. Sigma is basically the standard deviation. If a population follows a normal distribution, the sample distribution of a sample mean will also follow the normal distribution. This is as same as we have discussed before. T is equal to x bar is equal to mu of x is equal to mu. So these three will be equal, or you can say these three will be normally distributed if the population is distributed. So if the shape is known to be non-normal but the sample contains at least 30 observation. So in previous chart we have seen the shapes like um, this. This is the non-normal shape of a curve. But when n approaches to 30, the shape is changed to a lot more normal. So the central limit theorem guarantees the sampling distribution of n follows the normal distribution. So when n reaches to 30. To determine the probability of sample mean falls within a particular region, use. So how we can find out that where the sample mean is falling. So that particular region, we can find out the region by using Z distribution. The formula is Z is the distance from the mean measured in standard error units. So this is as similar as we have discussed in chapter 6 for the normal distribution. And we have calculated the x bar. X bar is the value of sample mean in which we are interested, minus mu. Mu is the proportional mean. So the formula for proportion is number of successes divided by number of trials. I'm going to write the hash for number of success divided by number of trials. So this is the formula for proportion. When a discrete random variable is expressing the sample proportion. Okay, then move on to the standard error, this terminology. So you can write this expression like this, but we can also write the Z formula in this form. sorry, this is going to be sigma x bar, and this is basically going to equal to sigma divided by under root n. So basically they wrote the detailed form here. This is the population's standard deviation. Population standard deviation. So let's move on to the next slide. When sigma is unknown. You know, when sigma is unknown, so the formula will be same, but we will going to have a t except z. So let's see what is the description here. If the population does not follow the normal distribution, but the sample is of at least 30 observations, the sample will follow the normal distribution. This is um, same. To determine the probability a sample mean falls within the particular region used, t is equal to x bar minus mu divided by s divided by under the root n. So t is a different distribution. So we are not going to discuss here that how we can going to find out the t value. So let's move on to the next slide. When sigma is known and the given example is relevant for the sigma known for sample distribution. The Quality Assurance Department of a cola incorporation maintains record regarding the amount of cola in a jumbo bottle. The actual amount of cola in each bottle is critical, but the varies of small amount from one bottle to the next. Cola incorporation does not wish to underfill the bottles. On the other hand, it cannot overfill each bottle. Its records indicate that amount of cola flows the normal distribution, the mean amount of per bottle. This is the mean amount of per bottle, and the population standard deviation. And population standard deviation is also given, which is zero point 0.4. At 8 a.m. today, the quality technician randomly selected 16 bottles. He has selected 16 bottles from the filling line. The mean amount of cola contained in a bottle is this much. So this is the sample and this is the sample mean. I'm sorry, if you can write down as x bar because it's a sample mean x bar. This is the population mean, we will write here mu, okay, and this is the standard deviation. So all the information is given for the z formula. Is this an unlikely result? It is likely the process is putting too much soda in the bottle. To put it another way, the sampling error is 0.18 ounce and unusual. So standard error is also given. So moving on to the next slide, let's see how this come. Okay, first step, find the z value corresponding to the sample mean. So they have put the values into the Z formula. X bar is 31.38 and mu is 31.2 divided by standard deviation divided by n under the root, and this is the Z value 1.80. So now they have plotted the Z value on a curve. Find the probability of observing the Z value equal or the greater than 1.8. So this is these are the ounces given. At mean point, there were 31, and at z point, it is the 31.38. So the shaded area is 0.359. The shaded area is basically subtracted from zero point 0.5 minus 0.4841, and it is equal to 0.0359. So the sampling distribution of mean amount of cola in the jumbo bottle. So there is 3% probability of uh, cola in a jumbo bottle. So moving on to the next slide. So they have wrote the conclusion here. It is unlikely less than a 4% chance we could select a sample of 16 observation from a normal distribution with the mean of this and this and standard deviation of this, and find the sample mean equal or the greater than 31.38 ounces. We conclude the process is putting too much cola in the bottle. So they are saying that the process is putting too much cola in the bottles because it is above the mean level. So I think our chapter 8 is end here. So in next lecture, we will going to study the point estimation chapter 9. So before next week, please try to do all relevant numericals of this chapter. Thank you so much. Assalamu alaikum.